All right, good morning. So I'm going to talk again about IP optical convergence, right? So it's the theme of this session, of course. So what I want to focus on is beyond technology, right? So of course the technology is the starting point, but I want to look at kind of what is the end-to-end picture, because we vendors, we like to talk about kind of the technological components, but then how are finally our customers using this in the networks, right? So I think that's a bit more interesting these days. So I want to point out that just my vendor head up for a few seconds, that we're kind of market leader in both IP and optics in Europe. Right? So we have, for service provider networks at least, we have biggest market share in both domains. And so we try to differentiate in both domains, of course. But then what we see as well is that by having customers actually mixed IP and optical, we have customers only taking IP from us, only optical. So I think we're in a good position to look at both sides and say what is, depending on the customer situation, geography, type of services they offer, and so on, what is the best way of connecting these worlds together, right? So you can, of course, use the innovation on both sides, but innovation is sometimes also on the way you connect these things. So agenda-wise, I think I need to start with technology, right? So what do we have? What is existing today? And then going a bit more into kind of the practical implications of doing that. When you talk about IP and DWDM combination, of course, the last couple of years, we've focused a lot on 400. That was the driver for everyone, 400 ZR, ZR Plus, and so on. Need to see where it fits into the network. So we see this, of course, growing. At the same time, we need to think about kind of the bigger system, knowing that because of capacity increases and so on, people are looking at not only 400, but more and more 100 ZR into the access, of course, and then going as well to 800. So when you look at how do we bring these worlds best together, I want to take it beyond 400 ZR, and that can go to the lower end with 100 and to the larger end with 800, right? And these networks need to be optimized, both for OpEx and CapEx, of course. And so what are the technologies that are of interest to optimize these networks? Is on one side, innovation that is happening on the router side. That is typically my area, to make sure that routers can cover all of these different speeds in the best possible way. There is advancements also onto kind of the pure optical side. Again, focus a lot on 400 ZR. I think that's the reason we're here, right? That it's on the agenda for the last few years. But there is also equally evolution on pure transponders. Sometimes when you hear these presentations, it's as people think that one day to the other, everybody's going to throw away transponders and we'll have only ZR pluggables into the network. So innovation, of course, on both sides. Then how do we bring them together? What we typically call coherent routing, combination of doing the routing side, but then in kind of with coherent connections directly on the router or not. And then more important, and that is, I think, today, when I talk to customers, it's typically the topic where we spend most of the time, is how do you bring this together in a coordinated way, right? Of course, you can purely focus on kind of the cost of a pluggable or the cost of a transponder, but ultimately it's about the services that you offer to your customers and what are the best ways of getting these services across. Slides like this or similar, you've probably seen many times if you're kind of looking at IP optical. Basically, the choice you have today is what I would call the traditional way, where you put your gray optics into the router and you have transponders separate, right? And these transponders, of course, as I said, they evolve as well. Or you go direct to, with the DWDM interface into the router. Right? So, and there is a use case for both of these. Actually, I was talking to a customer 1 or 2 weeks ago, talking about an 800 gig circuit of 2,000 kilometers between the Netherlands and Switzerland. I can tell you that even for like a very dedicated transponder optimized, it's already challenging enough to do that, right? So it's going to take some time for us to do this to do this on a pluggable anytime soon, right? So both of these on the transport, and then of course the coordination is a key aspect to all of that. Right. So looking at the building blocks, the optics, of course, evolution there. Discussed also previous presentations. I think especially the Sienna one, I really liked it. It gives a bit of a view on where we're going. But then, of course, these are pluggables you need to put into a router, or can be in a separate transponder. And then, of course, there is an evolution also onto kind of the line systems. But what is important is this cross-domain view that you need to have across both layers, right? So IP and optical. And then there, what I learned is that on an IP side, and I think most of the people in the room are probably having an IP background, we talk MPLS or similar, and at the end, topology doesn't matter too much anymore. We will fix it. On the optical side, it's not that obvious, right? So topology is important, how these things are getting connected over an optical network. Right. So pluggable optics first. Just a bit of a repetition, right? We started with ZR. Evolution there is, as I said earlier, 400. Yes, that was the driver or the driving point. So 100 ZR is coming in a few weeks, months. 800 is coming in a few months. Right, so that evolution needs to be across the board, typically used for kind of single fiber span. In reality, it's kind of a DCI interconnect or kind of very kind of dense aggregation. We can see this as well. ZR Plus, two options, right? The option with the pluggable different modulations and evolving also to 800 gig, and then an optical transponder, right? So I think technology that was covered quite a few times already. So let's move a bit of a slide for the IP guys in the room, that we tend to think about an optical interface as, okay, I'm getting my lambda directly onto the router and it will go across the network and I'm done, right? I will put this to maximum power and then I will get to the other side and my life is easy. If you look at a bit deeper on what's happening on this kind of this optical line, DWDM, there is a lot of complexity even there, right? So let's not oversimplify what needs to happen there. Of course, from the multiplexing that I think we get, right? You want to have more of these channels across the same fiber, but things need to happen to kind of optimize the distance, to be ready for fiber cuts, protection, and so on. So there is a lot of technologies on the optical side that we typically don't see with our IP, from our IP view. And so that means as well there is components into that optical network that are making this possible, right? From, again, a multiplexer we get, amplifiers as well, but then as soon as you start talking about dynamic gain, equalizers and so on, it's for an IP guy, it's a bit more difficult to grasp all of these requirements, right? So I want to make you aware that this is a language that you will have to speak if you think about IP optical convergence in a good way there. And then if I look at kind of how the pluggables that we're selling today, so we have, of course, 400 ZR in our portfolio, ZR Plus, 0 dBm, all of these things. If I look at how are they doing today, what is interesting to see is that many of my customers are testing. In Europe alone, I think between 30 and 40 at this point are testing the technology. If I look at deployments from a volume point of view, it is all kind of web scalers. It's a quite interesting aspect that the volume is really there, right? And the reason is that their use case is so much simpler, right? It's single span, high capacity. I want to get to distances I can cover with my ZR technology. But then if you look at the network of a typical service provider, it's a bit more complex than that, right? Of course, you can run the network as all individual links. I know some customers are doing that, but in reality, your network is much more heterogeneous. A lot of things that have grown over time, fiber links based on geography, where services are picked up and so on by customers. So it is much more complex. So that means you also need more complex tools to make this possible, right? So when you look at all of this technology and you see the numbers, right, you've probably seen these graphs of take-up of 400 ZR, ZR+. These graphs are completely, heavily influenced by what kind of web scalers and data center interconnect is doing, much more than what we see in the telco space, right? So the options on all the pluggables, and again, I think Jenna did a great job to kind of explain what the evolution that we're seeing, right? So what is interesting is, depending on that evolution, there is also, and as a consequence, kind of the relationship with the optical topology of the network, there is different requirements, or these pluggables will actually have different requirements from a power and hence cooling perspective onto the boxes where you're going to fit them in. Right, that goes traditional, what we have, or today what we have in mind is around 20 watt, which is quite a lot, right? I have to put that in perspective, and let me move maybe directly to the next slide, that you need to put this into a box, right, where to give you an idea, and actually this is kind of the chip that we are using to do 800 gig, right? You can do 800 gig today on the router. My 800 gig is roughly around 80 watt that it's using, right? To get my 800 gig across my router, I probably need around 80 watt. And now we're talking about pluggables that will be put into my router that are 20 watt, 30 watt, and even higher, as we've seen. So you see that the design perspective for a router is very heavily influenced by the fact that you're going to put these coherent pluggables, right? So we've designed for 30 watt plus. Right? So that means you need to do some things into the design of the router to make sure that these plugs will be accepted and that we can still cool them. So we have some technologies that we've used into kind of the latest generation of routers to make that possible. So today, the situation is when I go to customers, typically I go together with my optical colleague and we discuss IP optical. I always make it an optical problem. And the reason is that from a router perspective, I don't care. You have 36 cages, you can do 800 gig on them. I don't mind if you put 800 ZR at the end of the year, you put 100, you put kind of gray optics or not, I don't care, right? So I've built a router that can cover any possible combination of coherent pluggables. Going for it or not is an optical problem. Depends on distances, quality of your fiber, the topology that you have, your ROADM locations and so on, all of these things. So I make it an optical problem. I made my router such that we're flexible. Right? So that is a very important aspect. What we see with some customers is that, yeah, they have systems where, okay, they want to do coherent, but yeah, you cannot do this on this cage, or if you do it on this cage, you cannot use the cage next to it. I don't think that is, when we're planning a network, that is the right way to go. So that is from a router perspective. And then bringing it together is probably the topic where we spend most of the time when going to customers is, how will I manage this? Again, for the typical web scaler data center interconnect, it's relatively easy, right? It's kind of point-to-point links. There is not too much to take into account. Once you go to more complex technologies over longer distances, you need to take into account so many more things that you need to be aware of. Right? Again, from my perspective, it's more of an optical problem than really an IP problem. However, it would be naive to say, forget about the optical layer, I'm only going to focus on IP. Right? So we need to be aware that this is happening. So in an ideal case, well, the situation that we see with many customers today is that the two domains are very, very separate. Literally, I think in more than half of the customer communication I have, I'm the glue between two departments. Right? I talk to the IP guys, I talk to the optical guys, and they don't necessarily talk to each other in all customers, right? So it's kind of the first point. So they see their own network. What we want to bring into the picture is that, well, at least they see each other's network, right? So that a wavelength is not a pure optical thing or a pure IP thing, but at least they speak the same language, they have the same view. And then once you do that, that's the starting point, right? That at least they understand the same wavelengths, and then this allows you, well, once you have that capability, you can see multi-layer, you can do more optimizations, you can do what-if scenarios, there is so many more things you can do. But the starting point is really that they see the same wavelengths, right? Which is, they're not always tuned to the same frequency, let's put it that way, right? So it's a very important aspect, which today is where most of my customers are struggling to do that. So how do we do that technically? I know there is different solutions. Again, my view is it's an optical problem, so that's the first space where you need to look at. Right? So the way we see things being managed, or to create that common view between IP and optical, is to make sure that the optical controller controls the plugs. And you cannot, from a router point of view, you cannot decide on what is the right power I need to put, what is the right frequency. All of these other parameters that need to be set can only be done for someone who has end-to-end view on the lambda, right? So it's the optical controller, and in our case, it's WaveSuite, is the name of the product, that will control the plugs. However, what we hear from most of our customers is that the IP guys, being a different team, they don't really like an optical controller to come directly to the router to configure the plugs. So the way we see things is that we go through a TAPI interface, a standardized interface from ONF, with the purpose of telling a multi-domain or cross-domain coordinator to configure the plugs into the router. So it can actually, it's the IP controller who will ultimately configure the plugs, will also do the kind of the monitoring and so on, but it's the interface between the two is a standardized interface that is called TAPI. Right? So that is, and we call that kind of open terminal control. So from the optical controller point of view, it sees the full network, but it's actually IP router that is configured. So conclusion, or the point I wanted to make is that, yes, we've seen a large uptake already on 400ZR, 400ZR+. It's a very kind of, not in volume, but in, especially for this room, I think it's a very niche, I would call it, right? It's data center interconnect where we see this deployed. Of course, there is also already telcos, but it's still very small. But we're ready, the technology is there. The problem is, well, not the problem. The first thing to do is to look at, from an organizational point of view, how can we get this across, right? Technology-wise, we are there.